Ever tried to write a complex research paper while your desk looks messy? You spend 10 minutes just looking for a pen? Your brain is stalling before you've even written a sentence. You're frustrated, your focus is gone, and eventually you just give up. Now imagine this. Everything has its place. You can actually think. In deep learning, your model goes through the same thing. If you put your normalization layers in the wrong spot, your model's brain is essentially this messy desk. Today, I'm going to show you how moving one single line of code can make your training 3 times faster and infinitely more stable. Let's look at the mess first. This is called post-norm. It was the old way to do things in the original transformer paper. We do the work, add it back to our input, and then we tidy up with layer norm. Notice how forward output looks perfectly fine. Shapes are correct, gradients exist, and nothing crashes. But this is the sneaky part. The instability only appears when you stack many of these blocks during training. That's when exploding gradients and not a number or NaNs creep in. Now you might hear about batch norm. Think of that like an office manager checking every desk in the building to make sure they all look the same. It's great for images where data is consistent, but in the code I just showed you, we are using layer norm. That's the personal version where you just focus on your own workspace, and it's the gold standard for transformers and LLMs because it doesn't care about what the rest looks like. But here's the kicker. Even if you have the right cleaning tool, such as layer norm, using it at the wrong time is what's killing your speed. If you tidy after the chaos, post norm, you're constantly reacting, but if you tidy before you start, everything changes. Look at that. The forward output still looks perfectly normal, just like post norm. The difference is subtle in a single block, but when you train deeper models, pre-norm keeps the gradients healthy and training stable. By cleaning the desk before the heavy math starts, you don't need a massive learning rate warm-up, and you can push your model harder without it exploding. This is exactly why GPT-4 and LLaMA adopt this design, the secret to stability. In AI engineering, we often look for the big complex answers. More data, bigger GPUs, more layers, but often the secret to a state-of-the-art model is just better housekeeping. Go move your norm layers to the front of your blocks today. I bet you'll see that loss curve drop faster than ever. If this made the math click for you, drop a broom emoji in the comments so I know the tidying analogy hit home. Subscribe for more such moments in AI. Happy training. Thank you.